Alright, so number 3, we start off by identifying the end behavior. And so remember, we look at the leading term right here. That'll determine the end behavior. The odd power or odd degree tells you that the ends go in opposite direction. And then the positive coefficient is telling you that on the left side it goes down and on the right side it goes up, like that. Okay, so for now, I'll just leave it at that. The notation that I usually write, you know how it goes. So it's going to be negative on the first one and positive on the second one. For the y-intercept, because there is no constant, the y-intercept is going to be 0. So now we go ahead and we factor. So the greatest common factor here is 5x. And so I get x squared minus 4x plus 2. Okay, so this one does not, this quadratic does not factor. Okay, so I have to use the quadratic formula that says x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. So the opposite of negative 4 is 4. And then b squared would be 16. Minus 4 times 1 times 2, that would be 4 times 2, 8. Divided by 2 times 1. So that's 4 plus or minus square root of 8 divided by 2. Now for 8, it's 4 times 2, so the 4 square root of 4 comes out as a 2, right there. And then this one stays inside. I can factor out a 2 out of the outside numbers, and so that reduces to 1 right there. So my zeros are, for here, I get 0. And then from the quadratic formula, I get 2 plus or minus square root of 2. So those are 2 zeros right there. So a total of 3 zeros. Multiplicity of each of them is 1, so that means that the graph is going to cross through on the x-axis at these zeros. So I went ahead and calculated the 2 plus radical 2 and 2 minus radical 2, and you end up with 0.6 and 2.4. And then let me just rewrite the 0 right there. So these are the 3 zeros right here that we're going to plot on the graph. And then we're going to get an additional point or 2. So so you take a look how this is how you determine which additional points to pick. You look at all your zeros. It goes from 0 to 2.4. So in between 0 and 2.4, I have 1. And I have 2. So I'm going to calculate the values for f of 1 and f of 2, and oh, sorry, I wrote a number wrong. Eesh. This is actually 3.4, not 2.4. And then I will also do f of 3. Okay, so f of 1, replace all the x's with 1, and so you get 5 minus 20 plus 10. So that gives you negative 5. When you plug in f of 2 into the problem, you get 40 minus 80 plus 20. So that gives you negative 20. And then when you plug in f of 3 in the problem, you get negative 15. Okay, so that's when you put in place of the x's right here, you put in the 3. And you simplify, you get negative 15. So now we're ready to draw the graph. Now there is no symmetry. It's not even, it's not odd. So it's neither. And I have, let's see. Okay, so I created the XY plane right here. Notice how on the Y-axis I'm counting by 5s, every tick mark. And the reason for that is because I saw how big these, or how negative they were, like -20, -15. So I made my y-axis count as every tick mark as 5. On the horizontal axis, I just counted every tick mark as 1. So let's go ahead and plot the points. So 0, and then 0.6 is approximately right here, and 3.4 is approximately right here. And then 1, -5, 2, -20, 3, -15. Approximately right there. Okay, so with that we have, we know the end behavior on the left side, it comes in from the bottom, so it's going to come in this way, then it curves back down, and it curves back up, and there's the graph. Now, this is not necessarily the lowest point. Actually, when you plug this formula or this equation into Desmos, the lowest point, the relative min, is actually 2.387, -22.808333. That's where the lowest point is. So it would actually be a little bit, maybe about here, when I'm drawing the dot. So it would actually go down a little bit further and then back up. But on the test, I do not expect you guys to have this number. I'm just telling you right now so you know. So check on Desmos. That'll give you a more accurate graph. Alright, so the end behavior for number 4, again, I'm looking at the leading coefficient or the leading term, and so I know because it's a positive coefficient with an odd exponent that the ends are going to go like this. Okay? Whoops. Alright, so as I was saying for number 4, the end behavior is based on the leading term. You look at the power. If it's odd, the behaviors at the end go in opposite directions. So if the leading coefficient is positive, it does this. Up to the right, down to the left. Okay? I set up the problem for the box method factoring. So notice I put them in order from the first term, second term, third term, fourth in standard form. So how you do this, how you use this method, is you take the greatest common factor of this row, which happens to be x squared. So that's what you write out here. And then you ask yourself, what times x squared gives you x cubed? The answer is x. And then what times x squared gives you -2x squared? The answer is -2. And then what times x gives you x? The answer is 1. And you check the last square. Is -2 times +1 equal to -2? The answer is yes, so that means you factored it correctly. So the two factors are x squared plus 1, which you get from here, and then x minus 2, which you get from up here. Okay? And that equals, you set it equal to 0, and so that means each factor has, that's how you find the zeros. You set each factor equal to 0. Well, this one's going to have no real root, or no real 0. And this one, x equals 2. That's the 0. So it only has one real 0. The multiplicity is 1, because this is a 1 up here. So that means that at 2, the graph is going to cross. When the multiplicity is odd, the graph crosses the x-axis. Okay, so, and the y-intercept is 0, -2. Again, we get that because that's a constant right there. So we set up the x and y. Okay, so you plot the points that you have, 0, -2, and and then 2, 0. And then you also know, let's see, you calculate the additional points. So I'm going to calculate 1, like I'm going to find f of 1. So that's 1 cubed, which is 1, minus 2 times 1 squared, which is negative 2, plus 1 minus 2. So then that gives me 2 minus 2, that's 0, minus 2, that's negative 2. So right here at 1, it's back at negative 2. So these points right here are lined up on this, on the same y. So I know that it's coming in from the bottom on the left side, so I'm going to connect, I'm going to go, let's see, draw it. It's going to come in this way. And then at some point, because it doesn't go straight across to 1, negative 2, it's still curving up a little bit, then it comes back down, and then it goes back up. Now, how high this point right here is, that one you would just either have to, if you want to, like, you could find another, like do another f of 1/2 or something, but for our purposes, this is enough. What I drew here is enough. Now on Desmos, when you plug it into the graphing calculator, you will find that this point right here, the highest point right here, which, you know, I just graphed it however, but when you plug it in, that relative max is 0.333, so I imagine it's 1/3, negative 1.852. That's a decimal right there. So those are the coordinates of the point that is right here, the point right here. And then this one, 1, negative 2, happens to be the relative min. Okay, and that's the graph for number 4.